So now I want to show you a few examples that illustrate how this would apply. So I took two examples for today's discussion, both of which come from rail transportation. So there are problems with rail wheels and their conditions, and there are problems with switching equipment used in rail transportation, both of which require a lot of manual inspection as well as incur delays and fines when things are not done on time. So let's first take a look at the rail switch. Rail switches, as they are electromechanical in nature, produce not only the mechanical behavior but also electrical behavior. And what we are looking at here are the recordings of electrical behavior that are encountered in that switch. Now, this is showing us three different patterns that were recorded at different periods of time from one or more switches. Now, if you look at them, the human eye is able to distinguish between some of these patterns. And there is a relationship, as established by experts in the domain, between these patterns and the conditions that we are interested in, such as whether it is operating healthy, whether it needs some attention, or where things have reached close to breaking point. So we want to be able to create an automated system to recognize the patterns and immediately translate it into the conditions that can help us perform the right action. So to do that, Falkonry naturally can take the pattern, can take a label that a human expert can provide, and of course the name would be what the human expert deems is appropriate, and then understand the relationship between the data and the patterns that are present in it and the labels that people care for. So in some ways, this is a simple supervised learning approach. Of course, in addition to the learning that goes on, there's also feature extraction that has to be performed. And so Falkonry has to combine good feature recognition or feature extraction on temporal data multivariate, and then combine it with labels that are provided by experts. That itself is challenging. It is even more challenging when the number of examples available are very small. Now, this is the reality in most operations, that there is not a very systematically curated data set that is available to create a classifier. And so Falkonry has come up with ways of learning a good classifier based on a very small number of labels that are made available in advance. Here's another example where you can see all the different things that Falkonry would be able to perform. So let's say that the bottom charts are indicative of the data that is collected in the field. From this data, Falkonry can automatically discover patterns that are present and represent those patterns in the form of different colors. So for example, the green, the blue, and the yellow color. Now this yellow color is a relatively rare occurrence, and in this case arises as this vehicle. In fact, this is data coming from wayside or trackside sensors that are monitoring wheels of locomotives and rail vehicles. So the yellow pattern is indicative of a problem that is observed in this data. Now you can notice that this yellow pattern was discovered, but no meaning was available for that pattern. And that good AI, because of its feature engineering, can discover these patterns on its own. Later, when presented with this information, an expert can differentiate between a failure level and a pre-failure level. So these types of inputs can be provided by an expert in the form of a fact. And then Falkonry can incorporate these facts as well as the original data so that it can create a classifier that speaks the language of that domain. And now Falkonry changes colors of the results it produces to indicate the learning that has taken place in the form of normal, early warning, and failure levels. So this is, in a nutshell, the combination of techniques that is necessary in an AI technology for data-driven operations. Moving on, let me tell you how this AI gets delivered. One of the obvious questions that many of you would have is that there are so many domains. Every domain will have a different set of conditions and a different set of data that they care for. Falkonry's approach is to make available this condition recognition as a service, which means that whatever operational data management technology you are using, whether it is Splunk or in industrial technology like OSI Soft or in enterprise technology like Salesforce, can receive data streams from external sources. Falconry then plugs into this environment where selected time series can be brought into the Falconry AI that is available as a service, and where the results of Falconry's AI would be delivered back into the operational data management environment, from where various people can build various applications, workflows, notifications, dashboards, etc. Inside of this AI assistant, Falconry has eliminated the need to do rules and formulae, queries, and visualizations, and instead, Falconry goes directly from the raw data to conditions like we looked at earlier. This is the schematic of the AI assistant. It's actually a very simple approach in the form of a data flow. There are flows of data coming in. This is where time series data from multiple sources can be fed into this AI model. Over time, many different versions of the AI model can be created, any one of which would be applied to the incoming data flow. That incoming data flow is then translated into condition assessments, which are continuously made available in the form of an outflow. Models can be improved both with availability of more input data, but also through facts that are provided by a subject matter expert. So naturally, this means that Falconry is doing semi-supervised learning in addition to the temporal feature extraction that we were talking about earlier. This schematic actually explains to you what happens inside Falconry, where Falconry is able to achieve a correct structuring of raw time series data so that it can extract features from it. And these are a variety of feature extraction techniques that Falconry applies. And these feature extraction techniques enable a good feature vector to be created that is representative of the information present in that set of time series. And then Falconry is able to provide the right hyperparameters to use with all these algorithms that are themselves derived from the raw time series data. And so Falconry uses an adaptive technique to produce a temporal feature vector. Now, if you think about conventional approaches of feature engineering, it has been believed in conventional approaches that this cannot be done in an automated manner. Well, with Falconry, our customers are in fact using the technology that I'm showing you here to do autonomous and adaptive feature extraction directly from the data without the need for any program. Techniques for clustering, classification, as well as outlier detection to translate the numerical representation of all of the features into the language of conditions that are easily understood in the domain. These results, as well as the discovery of unknown conditions, can then be presented to a decision maker that is able to act upon the Falconry findings. That action can be either in the form of additional inspection performed on the ground, or it can be in the form of automated behavior that is executed in response to the conditions discovery. In either case, experience from the field can be brought back in as fact that can be used to further improve the classifier that is able to produce these conditions. Now, this cycle can be continued forever, and at no point of time does any programmer or expert in the field of data science need to work with Falconry to make this better. And this significantly changes the life cycle of the use of machine learning as well as data-driven techniques for the purposes of improvement of the operation. This is one of the reasons why operations experts as well as industrial and IT teams like Falconry, because it enables them to take control of their own destiny. Inside of Falconry, we have created a multi-layer architecture where the algorithms and techniques that are used for window selection, feature extraction, semi-supervised learning are executed on top of an in-memory distributed architecture such as Apache Spark. This entire technology platform is able to use data that can be buffered in Falconry or data that is being staged external to Falconry. And that means that customers' data can lie wherever it is being collected, and that they can layer this AI on top of it. This is extremely important because a lot of people have been collecting data for sometimes many years and have very stringent requirements for the governance of that data. Lastly, I want to summarize how Falconry is providing benefits to its users. As we saw, there is no programming required, and it can be used directly by a subject matter expert. Secondly, Falconry provides deployment flexibility so that it can be embedded inside applications, deployed in the cloud or on the premise, and can be split between the learning and the monitoring aspects of this AI. Because of this approach, a customer is able to truly secure their intellectual property and not have to explain to external agents what problems are being solved and what data is being born to solve these problems. And then lastly, Falconry is able to do all of this in real time, which means that customers are able to use all of the data to improve their operations and its efficiency.